Okay, welcome. In this video we're going to create a TP script operator that's going to create an alignment using a matrix function from MaxScript. That function's found on matrix 3 values. It's called RotateYPR matrix. It takes a yaw, pitch, and roll. So we're going to need 3 values, and it's going to return an alignment value that TP uses to orient the particle. We don't actually have a matrix access to TP, which is a little interesting. It's kind of broken out for you into things like position, alignment, and scale. Those things would normally all be stored in a matrix, or at least a matrix 4 value. But in TP, it's going to be dealing with these separately, and so we'll keep that in mind as we go. Okay, let's go ahead and on our DVD, under Assets, Script Operators, Template, we've got that template function. Let's get our MaxScript window open, and we'll go ahead and get started. And remember, we're going to end up wanting 3 kind of UI controls. We're going to go ahead and end up using the angle control. And for some strange reason, you know, I'm not a great MaxScripter, just enough to be dangerous. But if you use purely the angle values and you try to use that RotateYPR, couldn't get it to work, so I ended up having to also add spinners. So we'll add a set of angles and then also a set of spinners to work with. So the first thing we'll do is we will save this so that we don't end up overwriting our thing, our template. And we'll call this AlignmentYPR-tutorial. Let's go ahead and grab that name because we're going to need it here in a second. And what we're going to do is just do the Control H inside that. We're going to call this AlignmentYPR-tutorial, and we'll just go ahead and replace all. Because in the template, if you do a replace all, in that case, it will. We don't have any other values in here that it would end up replacing. Unless you call your operator float or particle or something brilliant like that. Okay, then we're going to need a new class ID, so let's generate one of those. And now into the good stuff. Actually, we'll come back to parameters. We're going to go ahead and wipe out that description stuff. And instead, we're going to jump right into the rollout. In the rollout, we're going to take a look here under the angle. There is a set of parameters that we're going to want to use, or a construct. So we're going to declare an angle, its name. We're going to go ahead and call this one yaw. And remember, if this is our little alignment helper, yaw in airplane terms is a rotation around the z-axis, because it kind of tilts your plane one way or the other. Pitch is rotation around the x-axis, so it's going to be red, and then roll, being rotation around y, is going to be green. So that we'll just use those colors to match what we're doing. So the color for yaw is going to be blue. Let's check our reference degrees. Set the current angle in degrees. So the current, we'll go ahead and set it to 0, or maybe we need to leave that undeclared. We'll find out here in a minute. But the diameter of this angle object in our UI, I'm going to go ahead and say it's going to be 40, because I'm pretty sure that the TP UI is about 120 units wide. Okay, starting degrees. This is actually going to control the orientation of the angle spinner. We'll take a look at what we have to do in that in just a second. Let's set it to 0 to begin with. And we're not going to be dealing with radians unless you're able to think in radians. Be impressive. And then a 0.3 for the range, so we're going to need the minimum value, the maximum value, and then the initial starting value. So that's going to be yaw. We'll just kind of duplicate that for pitch. Roll, remember, is going to be green. Pitch will be around the x-axis. That's going to be red. And so those are our angles. And then, of course, we are also going to need our other favorite, spinners. Spinner name, you know, we forgot to declare the angle names. We'll call this yaw angle, pitch angle, and roll angle. Okay, so for our spinners, they are going to end up being, they're going to match those three, except we're going to have a yaw spinner. And again, its range, it will be that very large value, because we don't really want to constrict the values that we're dealing with. Type, it's going to be a float. What scale? How many numbers to move per? You know, how fine, how granular is it? Field width. Which we don't really need field width. So we'll take that out. Tooltip, don't need it. Indeterminate, don't need it. Controller, set key brackets. We can go ahead and just leave our UI item like that. Okay, so and then of course we're going to have a pitch spinner, roll spinner. And I know I'm repeating a lot of stuff. It's my poor programming skills here. Okay, and then we're going to actually end up doing some controls so that when these are manipulated, they actually set each other's values. So you only have to set them once. But let's go ahead and actually declare the parameters that we're going to need for those. So if we start off, remember, with parameters, if you need any help or reference, remember to look under the scripted plugin clauses, where that's going to give you the kind of how this is all constructed. Here's our parameter section, what types that are available. Unfortunately, as far as I know, the script operator does not currently support tab values, so no array values. So we're going to have yaw angle. Its type is going to be an angle type, and then the UI corresponding item is going to be yaw ang. And we'll just do the rest of these, same kind of thing for these. Okay, and then also our spinners. Our spinners are just going to be of type float, and then the UI corresponding item, of course, is going to be the item with the same name. Okay. Let's take a look at our color type for this. We're actually going to have this thing be an operator, and I think we forgot to declare which category it's going to be in. Let's put one in here called M3D tutorial. And now that we're in the kind of the category world, let's jump down to the bottom where we register the actual function, and we're going to make this a operator type. And then we'll bounce around some more. We're going to just go ahead and comment out that input, because our operator is not actually going to need an input. What we're going to do, we don't want to set that particle alignment directly. We just want to be able to generate the alignment, because it's kind of handy to be able to use that to pass off to other functions or operators. We are going to have an output though, and remember, if you need a list of outputs, you can check the script operator alphabetized. It talks about all the different port types. Ours, of course, is going to be a type alignment. Okay, and then our function here, we do want to detect if there's an output being called, but we're not going to be detecting if any inputs have changed. We're going to take that section out. And actually, let's just go ahead and evaluate at this point. Okay, it throws an error for us. You know what? It doesn't like our name. Bummer. Let's go ahead and take that out. So instead of YPR, AlignmentYPR dash tutorial, let's replace and just put tutorial in. Actually, we could probably do the underscore, I think. No, still doesn't like it. Okay, what do we got now? End of line expected. Okay. Yep. Sloppy Mac script on my part. Okay, so that's fine. Let's actually update that name to be accurate and match, just so that there's no confusion. Okay, so we evaluate, everything turns out okay. Let's go ahead and create an operator. Here's our M3D tutorial subcategory, and there's our operator itself. And look at that, we've got the yaw, pitch, and roll, and those values there. One of the things that we want to do though is we actually want these to appear across. And another problem is that the yaw, pitch, and roll are all oriented kind of like in the math, circular chart. It's 0 is off here to the right. We actually want it to be oriented up at the top, kind of like a clock. So we're going to take a look at how we change that. And we'll go ahead and kind of reorganize these spinners so that they fit crosswise as well. Let's go ahead and take him out. To change that alignment of the starting point, we're going to change the start degrees. I'm going to set it to 90. We need to add another line to our okay, let's see if we can't get these spinners organized too. Let's go ahead and edit the rollout. How big is this guy? Width 62. I know you can do that. There's a function to actually make them all match. It doesn't really look like we're going to have enough room to stack them all nice and across. So we'll actually go ahead and give them a little more space. What is it? Space evenly. Probably messed this up. Space them evenly down. Well, that's a little too tight. Okay, enough of that. Let's get back into it. Save changes, yes. Okay, let's update our operator. It turned out okay. Let's go ahead and check it. Okay, so now our three guys here are oriented with 0 up at the top, and we can see those degrees being read off to us. And then we also have our spinners, yaw, pitch, and roll. Now what we want to do is we want to actually bind it so that when we make changes to either the angle or the spinner, it updates the other one. So that's pretty easy. Here in the rollout, we're going to go ahead and throw in some code and say on yaw ang changed value do yaw spin dot value equals value. Let's go ahead and evaluate and check it right then and there. Okay, so that one does okay, but of course we have to also do it the other direction. Let's go ahead and do the other angles first. Do pitch spin value equals val, and on roll ang changed. Okay, and then again for the spinners. So let's actually, it's one of the frustrating things about learning how to program more efficiently is I'm sure there's some huge shortcut for automatically kind of putting in these kinds of functions. So always so much to learn. Okay, so for the spinner, spin, spin, change do. Oops. Spin. Oops. Wow. Got the. There we go. Let's go ahead and update. Turns out okay. Let's go ahead and see what happens. Okay. Well, we got a problem there. Unknown property and value. Pitch angle control. Okay, so it must be a incorrect reference to that property. And in fact, the reason for it is because angles don't deal in values, they deal in degrees. These spinners are a little, their scale is a little too low. So let's actually correct that. Okay, so now we've got both of these talking back and forth to each other. Let's notice and say, okay, we're going to do 3/4, half, and 1/4. And come back, and we'll see that those are not set how they should be. And this is where we're going to actually have to end up adding some code so that it detects and fills those in once we set them. The way we can do that is by declaring some variables. Call it yaw val, pitch val, and roll val. Okay, and so we're going to actually have to change a little bit in our code so that when our yaw angle gets changed, it's going to actually end up doing two things. It's going to go ahead and set the yaw spinner to be that, and then it's also going to change the yaw val to also equal that value. And again, there's probably some faster, better way to structure this stuff. Sorry, but I haven't learned that yet. So pitch val equals val. And finally, roll val equals val. Okay, and the reason that we're going to end up storing all of these is because we're going to go ahead and set the starting value here for these rollout items. Right now, you see we've got the degrees actually specified. Just out of curiosity, let's go ahead and actually take that out first. We got a problem in our commenting somewhere, it looks like. Or not. Position 1, did we no, now it turns out alright. Oh, okay, now we got double. Well, we've got some bad mojo. Looks like we have some leftover user interface. That's not good. Let's actually go ahead and save this. Go ahead and save this scene while we're at it. DVD, videos, script operators. This will be TP4. ScriptOp. And this is going to be, what is it, AlignmentYPR tutorial. Wow. Caps just doesn't work sometimes. Okay, and then let's go ahead and reset max. Garbage collect just for good measure. And get that scene back in here. You know, I'm not seeing our object. There's our access helper. Wow, and we lost our viewports. Okay, well, in this case, we're going to have to restart max. Okay, we're back. Let's see how we do. We have it. No, because our script has not been saved into the startup directory, so it's not in TP yet. Remember, we come in here, and we'll go ahead and try this again. Okay, evaluates all right. That's good. Let's go ahead and throw our M3D tutorial out here. Okay, and let's try setting this. Remember, what we were just doing is we took out the degrees specifier in the angle, and now what we're going to do is test. We want to be able to make sure that when we leave this operator and come back, that the values are set the way they are. And they are not still. Okay, so we're going to have to add a little bit of extra code in here to set that up. The spinners keep those values, so let's just do something near 180 each. We go away, we come back. Those are still there, but the YPR values, the angles, are not. So we're going to have to add something in here that when this rollout opens, to either set those angles directly, or maybe we can just go ahead and say degrees equals the yaw value. Oops. Degrees to be the pitch. And roll value. Okay, let's try that. Let's just do a nice 180 each. Okay, yeah, so still not happening. We're going to have to go ahead then and roll ang.degrees equals. Oh, you know, part of the problem might be our default value setting there. Oops, not yaw val. Let's go ahead and comment this part out in case we don't need it. Isn't max scripting fun? Gosh, it's just, you know, like I said, you know, just a little bit, and that is enough to be dangerous. Okay, so we're going to actually go ahead and set these to equal something to begin with. Oops. I've got this new keyboard on here that's okay. How about that? Now look at this. Okay, so we come here, let's go ahead and set them all to a quarter. Okay, well, thank goodness. Alright, so that's all taken care of. Let's go ahead then and take out this stuff we don't need there. And so now you learn something new every day. We've got all these values specified here. Should we push our luck? Well, I'll do that in my own time. I was going to see if you remove these degrees specifiers, what would happen, but I'll do that on my time and not yours. Okay, so let's do this. Now we're going to go ahead and actually construct the alignment. We're just going to go ahead and grab that function out of the matrix. And so what we're going to do is we're going to go ahead and use the yaw val, pitch val, and roll val. Okay, so what's going to happen now is based on the user settings up here in these parameters in the rollout, it's going to go ahead and use those values, and when TP ends up calculating this operator, if an output is requesting our data, then it's going to go ahead and just calculate this matrix here. So let's go ahead and see what we get. Let's actually go ahead and turn our little matrix helper guy into a particle. Looks like he got renamed along the way. Two objects. What two objects? Pick him helper. Has an R there. Okay. Instances shape. It's all good. Let's go ahead and hide the original. And then we'll go ahead and tell all particles we're going to set their particle data. So we'll use the particle data operator, not to be confused with the particle data helper. And then we'll go ahead and use the input for alignment. And we'll go ahead and see what we get. Okay, I don't know if you can see this. There's some stretching on this particle. It's actually pretty wild. It ends up being really kind of stretched and tweaked out. That's because with matrices, we're going to have to actually end up orthogonalizing it, depending on which part of the country you're from and how you pronounce it. But there's this function here that you can read all about. Basically, it will correct this distortion and make it a true 90-degree angles to each other. So let's go ahead and add that to our code. Orthogonalize. And we're going to orthogonalize that entire item there. Go ahead and update. And look at that, he pops into place. Let's go ahead and, we could get nifty and like add some zero out buttons, but that'll be extra credit. Okay, now we have this interesting thing where the yaw is actually behaving like the roll. And this is something that we knew coming into this, but I can't explain it. I can't really tell you why, but I can tell you that if we switch and put the roll first and the yaw last, and leave the pitch there and reevaluate, then we get the correct kind of yaw behavior, pitch behavior, and rolling behavior. Well, roll is actually, something's a little bit wrong with roll, but we're going to have to troubleshoot that a little later. If you know why it does that, shoot me an email. Okay, so I think that's going to be it for AlignmentYPR. It's just mostly taking a look at how to construct things in the UI and setting up these values so that they work together, setting up the starting degrees and for these angle items, tying the two together. Whenever you modify one, it affects the other. And then of course it's a pretty simple function setting this rotate YPR based on those values, and generating a matrix or an alignment, which is then fed. And we can either set it with a particle like this, or if you ended up with, actually, I don't think the alignment operator itself has that. But I believe there are some other operators that do. But anyway, so kind of a fun little script. It's probably having to do with what space it's in, that, or maybe it has to do with the fact that it is experiencing some gimbal lock. So we might actually want to end up converting these into angle axes before we calculate that. Okay, so not quite a total success, but enough to kind of walk through generating UI items, having them retain their values, and then generating something that we can use then in TP.